Okay, well I'm going to write both these lines in this format. So line 1 is like xyz is equal to, so it's the point 8 minus 4, 3 plus, let's call this t times, and then we'll go minus 2 and 1. So you should be able to read that off from there, and you should be able to read off from here that this is xyz is equal to, and looking on the top line, it's 0 minus 2, 9, plus, call that lambda, and looking on the bottom line, it's minus 2, minus 1, and 2. Okay, so if you need a bit of an explanation as to why that is, you can see when you rearrange this, this says that x on minus 2 equals lambda, and y plus 2 on minus 1 equals lambda, and z minus 9 on 2 equals lambda. So x is equal to minus 2 lambda, and y is equal to minus 2 minus lambda, and z is equal to 9 minus 2 lambda. And so you can see how you can work that into the equation above by factorising lambda. Like this is a naught and plus and lambda times minus 2, and that's why the 0 and the minus 2 up there. And this is minus 2 plus and lambda times minus 1, that's why the minus 1, and so on. So it's good to write those two equations in that form. It's sometimes easier to see what's going on. All right, the question says, show that L1 and L2 intersect and find their point of intersection. So to show they intersect, we need a set of consistent simultaneous equations. So I need to show that the minus 2 lambda here that we found is equal to the x part of the other equation, which is 8 minus 2t. Sorry. So there's one equation, and then I need to, and then I need to show the y parts, which is like minus 2 minus lambda, is equal to, I'm just looking up here, the y part is minus 4 plus 2t. And the third one is the 9 minus 2 lambda is equal to the 3 plus t. Now you can solve any pair because there's only two unknowns. So you can solve any pair of those three that I've put in the box. But then that solution must also work for the third equation. If you have a consistent set of equations, then the lines intersect. See, it's possible for you to actually pick a pair that you can solve simultaneously, but that solution not to work in the third one. So that's an important thing to check. How about we just solve the first two simultaneously, like we solve these two, and then we'll check if the solution works in that third one for consistency. So just get a bit more room to work. Okay, so I'm going to solve those two simultaneously, but before I do this one, I could divide by negative 2 and just get lambda equals negative 4 plus t. So that might be now easy to go. I'm going to sub lambda equals negative 4 plus t into minus 2 minus lambda equals minus 4 plus 2t. So minus 2 minus negative 4 plus t equals minus 4 plus 2t. So minus 2 plus 4 minus t equals minus 4 plus 2t. So 2 minus t equals minus 4 plus 2t. 6 equals 3t, t equals 2. Okay, now sub t equals 2 into lambda equals minus 4 plus t. So lambda equals minus 4 plus 2. So lambda equals minus 2. Okay, now that works for equations 1 and 2. So check that t equals 2, lambda equals minus 2 is consistent, i.e. works also for the equation 9 plus 2 lambda equals 3 plus t. I think that's what it was. Let's have a look. The third equation with the asterisk under it, 9 minus 2 lambda equals 3 plus t. Whoops, I'm glad I didn't try to go by memory there. 9 minus 2 lambda equals 3 plus t. Now, is it 9 minus 2 lambda? Let's have a look at the top here. 9 plus 2 lambda. From my equation, you can see it's 9 plus 2 lambda. Yep, 9 plus 2 lambda. Z equals 9 plus 2 lambda. So I'm glad I'm actually focusing in on this. My mistake would have been good, would have been all fine in the end, but let's get this correct. So we want to check that that works in 9 plus 2 lambda equals 3 plus t. So the left-hand side is 9 plus 2 lambda, which is 9 plus 2 times minus 2, 9 minus 4, which is 5. The right-hand side is 3 plus t, which is 3 plus 2, which is 5. So yeah, it works. Therefore, lines, so left-hand side is right-hand side, right? Therefore, lines intersect. Now, they intersect, but what did the question ask? Didn't just say show that they intersect. Find their point of intersection, all right? And they intersect when lambda equals minus 2 and t equals 2. So you can pick whichever line you want out of the 2 points, the 2 lines that we've got at the top there, and figure out what the point of intersection is. So I might pick L1, right? X is 8 minus 2t. So X is 8 minus 2t. Y is minus 4 plus 2t. And Z, for that one, is 3 plus t. You could have picked the other line, it doesn't matter, because it's intersecting, so this works for both lines. So when t is 2, x is 8 minus 2 times 2, which is 4. Y equals minus 4 plus 2 times 2, which is 0. And z equals 3 plus 2, so z equals 5. So the lines intersect at 405. Okay, last part, they want to know, verify that the acute angle between the lines is inverse cos of 4 over 9. Okay, so the angle between the lines is the same as the angle between the direction vectors for the lines.